All right, so you've seen how you can tell based on the name or formula of a compound whether it's an ionic compound or a molecular compound. Now, if you were in the lab and you were given a compound, how can you tell based on its properties if it's ionic? Well, one thing ionic compounds tend to have in common is that they have very high melting points. The most common example of an ionic compound that you're most familiar with would be something like sodium chloride. That's your common table salt at home. You can try to melt it on your stove. It's going to take a very high temperature. I don't think you can get it to melt in the stove that you have at home. Okay, so if you do get it to melt, okay, then it's going to conduct electricity, and the reason for that is it's because it's made up of ions. Okay, so basically you're putting your sample, molten sample, between electrical electrodes that have oppositely charged. Okay, so that means there's one electrode, okay, one piece of metal here would attract the positive ions, and the other piece of metal would attract the negative ions. So you would hook it up to something like a battery. Okay, so if you have a battery like that, the positive end of the battery, and you have a negative end of the battery over here. Okay, in a battery, the electrons would have a tendency to travel out of the negative terminal, and so this part right here of the wire is going to be negative, so the positive ions will be attracted there, and then the negative ions will be attracted to the positive end, what we call the positive terminal. Okay, so when melted, it conducts electricity. Now, the solid itself is not a good conductor. Okay, and the reason for that is the ions will have a very hard time moving in a solid, whereas they have more freedom of movement in a liquid. So molten salts are good electrical conductors. The ions can move freely in response to what we call an electric field. Okay? Now, if you dissolve it in water, then these ions are going to be dispersed. Okay? So the ions are not really stuck. What happens is if you have, for example, sodium chloride, they're going to be stacked together right next to each other in a solid. But what happens if you dissolve this in water is they're going to spread out. Okay? And so the sodium ions here are going to be surrounded by water molecules. The chloride ions will be surrounded by water molecules. And they're more or less free to move about in the water. So when you put an ionic compound in water, it produces a mixture, a solution that is a good electrical conductor. So you say that ionic compounds are strong electrolytes. Now, you have to realize water itself is a very poor electrical conductor. It's a molecular compound. So why are you told to stay away from the rain? Why are you told to stay inside when there's lightning out there? And the water is a poor electrical conductor. The water, remember we said most samples of matter you see in nature are not pure. So the water you see out there, chances are it's going to have ions in it. So it's going to be a good electrical conductor. Okay. Now, what about molecular compounds? Molecular compounds, unlike ionic compounds, which all tend to have a very high melting point, the melting point of molecular compounds depends on the size of the molecules. Generally, the larger molecules would have a higher melting point, so they would tend to be solids at room temperature. But if you have compounds made up of small molecules, like O2, not O2, let's say carbon dioxide, CO2 molecules, okay, those are small molecules, and at room temperature, that's a gas, okay? It's already a gas. That means, what does it mean if it's already a gas? That means it was a liquid. To turn it to a liquid, you have to go to a much lower temperature. Okay, you have to cool a gas, remember, to make it a liquid. And so its melting point must be even lower than that. Okay, and for it to turn to a solid, you have to go to a much lower temperature. Remember, the melting point is where your solid turns into a liquid. And then liquid turns to a gas at a higher temperature. So if it's already a gas, it melted way before that, at temperatures way below room temperature. So carbon dioxide is part of the air you breathe. That is a gas at room temperature. That means the melting point of carbon dioxide must be very low. Okay. Now, most non-electrolytes. Most of them are non-electrolytes. That means if you put them in water, they're not going to conduct electricity. They don't have positive and negative ions that could respond to the electric field. Okay? Now, there are some exceptions. There are compounds that will produce ions in water, and these are the common ones you'll encounter are acids and bases. When they react with water, they produce ions, and so those are generally weak electrolytes, except for 6 compounds, which we call the 6 strong acids: HCl, HI, HBr, HNO3, H2SO4, and HClO4. That's hydrochloric, hydriodic, hydrobromic, nitric, sulfuric, and perchloric acid. These are the 6 strong acids that you just have to memorize. These are the molecular compounds that are strong electrolytes. If you dissolve them in water, you're going to get a strong electrolyte, a solution that conducts electricity very well. And the reason for that is these molecules, when you put them in water, they dissociate. Okay, that means they break apart into ions. For example, hydrogen chloride molecules, pure HCl, okay, is a gas. It's made up of small molecules, HCl molecules, but when you put it in water, the molecules break apart into a positive ion, H+, hydrogen ion, and a negative ion, which is chloride. And so that allows a solution of hydrogen chloride to conduct electricity. All right? So let's see. Which of these compounds is most likely to be gaseous at room temperature? Sodium chloride, methane, CH4, and CH18 is octane. Correct answer would be methane. Why? This one is ionic, right? Sodium is a metal, so you can see that sodium chloride is a metal. That's your table salt, right? That's going to be a solid at room temperature. Now, if you look at these two, these are both molecular compounds, but this is larger, right? The larger the molecular compound, the more likely it's going to be a solid or a liquid at room temperature. The smaller the molecules, the more likely it's going to be a gas at room temperature. What basically we're saying is larger molecules would have stronger intermolecular forces. They'll have stronger attractions for each other. They're going to require a higher temperature to be able to spread out. Okay. In fact, this CH18 right here is called octane, and these are the molecules in gasoline. Okay. And you know gasoline is a liquid at room temperature. CH4, on the other hand, okay, that's methane. That's the major component of what you call natural gas, fuel that you use to heat your homes. Okay. I'm recording. Which of these is not a good electrical conductor? See? Okay. Solid ionic compound, the ions don't have enough energy to be able, they don't have enough freedom of movement there. Solid copper, you might say that's a solid, but remember this is not a compound, this is an element, a metallic element. So all the metal atoms here have loosely held electrons that can freely move among the atoms. So that's a good electrical conductor. So solid sodium nitrate is the one that is not a good electrical conductor. And like we said before, any ionic compound that is molten or in liquid form would be a good electrical conductor. Okay? So the correct answer here is solid sodium nitrate. Finally, is HF, hydrofluoric acid, a strong or a weak electrolyte? It's a weak electrolyte. Why? You know it's an acid, so it's got to be either, most acids are weak electrolytes, with the exception of the 6, and this is not one of the 6 strong acids. This is not one of the 6 acids that are considered as strong electrolytes.